Algebra 1, Section 5.6, inverse variation. Before we talk about what this says, let's consider an example. Let's say that you and some friends are going to go in on a birthday gift for another friend, okay? And there's really two ways to do this. One way would be everybody throws in $5, okay? And however many people decide to throw in $5, at the end of that, after you're done collecting, well, that's the amount of money that you could go out and choose a gift. The other way to do this would be to decide what the gift is. Okay, we decided that we're going to buy this for this person, and it cost $24. Okay, and it costs $24, and if you end up having to pay for it all yourself, of course you're going to pay $24. If you can get one other friend to go in on it with you, well, then you each pay $12. If you can get two people to go in on it, then that would be $8 a piece. If you can get 4 to go in on it, that would be $6 a piece. If you can go 5 in it, that'd be less. If you get 6 to go in on it, that'd be 4, etc. Okay, so these two different scenarios identify the difference between direct variation and inverse variation. Again, the $5 model would be direct variation where it's $5. One person contributes. Let's do a T-chart. One person contributes. Well, excuse me, back up. 0 people contribute, no money. One person contributes $5. 2 people, 10. 3 people, 15. Okay. The other model is what's known as inverse variation. Okay. And what I just told you, what the example that I just used was 24. And that would be the K value. We'll talk about that in a second. But basically, again, if you have one person who is going to purchase this, that person has to pay for the entire 24. This is a division. 24 divided by 1 is 24. If 2 people go in on it, well, 24 divided by 2 is 12. If 3 people go in, it's 8. If 4 people go on, it's 6. If 5 go in, it's a decimal number. What would that be? $4.80? Yep, 4.8. 6 would be 4. And you see where I'm going with this, right? If you can get 12 people in on it, that'd be $2 a piece. If you can get 24 people in on it, they only have to throw in $1 each. Okay? So this is inverse variation. And the relationship is not linear. The relationship on this one, y equals 5x, linear. The relationship on this one, the graph actually looks like this. And considering the negative, it actually is in the third quadrant as well. Okay, now we're not going to get too much into the graph. We really only are going to focus on this right here. Okay, but that is inverse variation. A couple things about it. First of all, the K value is called the constant of variation, just like it was in direct variation. It's called the constant of variation. There's very little difference between the two, but the subtle difference that there is huge, right? Y equals kx and y equals k divided by x. Those are big differences. Okay, now also consider what we did in the previous video. And by the way, if you haven't watched the 5.5 video yet, you don't have any business watching this one. You should be watching the 5.5 video. What we did before was we plugged values in for x and y and saw that when we solve for k, we just multiply, or we plugged values in for x and y and we solved for k by using our algebra operations knowledge. You could do the same thing here. And if I knew an ordered pair, I could plug them in for x and y. You'd end up multiplying by whatever the x value is. Generally speaking, all you'd have to do is multiply by the x. Okay, I can do it in this form is what I'm saying. I don't have to plug numbers in. So if I multiply both sides by x, you'd have xy equals k. Now, once again, I'm going to strongly urge you to express things that are in direct variation like this and not like this. This would work. This isn't wrong, but this isn't going to model things in the way we like to see them. This is to help you find a k value. So if you know the x and the y and you can remember it, and specifically if you can remember the difference between inverse variation and direct variation, you can just know that with inverse variation, it's a product of the x and the y. That's a really quick one, right? So again, summary, direct variation, the last lesson, divide y by x, and you'll get the constant of variation. This lesson, inverse variation, is just the product of x and y. Multiply them. Okay, so a couple examples. Says suppose y varies inversely with x and a point on the graph. So this is saying that it's inverse variation. And a point on the graph of the equation is 8, 9. Now again, just one time, let's do it the long way. Okay, it's y equals k over x. And the y value is 9 when the x value is 8. And we want to find the k value, so you'd get it by itself. Since it's being divided by 8, you would multiply by 8. 9 times 8 is 72. The k value is 72. Then you can rewrite this equation with 72 in for k, and you have the equation. They want us to write the equation for the inverse variation. But really then, let's just take this to the conclusion that we're kind of leading to. All this work really isn't necessary, because all I really need to do is know that I need to multiply the y by the x, and the k value is immediately 72. 8 times 9. And we can write y equals 72 over x. Again, I like that better than x, y equals 72. This isn't wrong. This is the same form as this, or this is equivalent to this. It's of a different form, but they're equivalent. We like this for inverse variation. I think even the answer document does this. Sometimes I don't like it. Tend towards this. Okay, next example. The points 5, 6, and 3, comma y are 2 points on a graph of an inverse variation. Find the missing value. Now again, the graph of this is a curve that does not pass through the origin. So don't think in terms of the last lesson. Think in terms of inverse variation. And not only that, I'll tell you what I told you in the last one. I want to know k. I want you to write the equation. And then you can find the missing value y. This would be a 3-point problem on the quiz or the test. And if you can remember, and I keep saying if because I have had many students who just can't remember this, but if you can remember, the inverse variation is the product of these two numbers. It's 30, just like that. The constant of variation is the product of 5 and 6. The equation then is y equals k over x, which is 30 over x. Just like that, y equals 30 over x. Again, this is 1 point and 1 point on the quiz, and this would be a point, probably. At least a half, and 1. And then you can find the answer to the question by considering this ordered pair. Find y when x equals 3. Well, we would plug 3 in for x, and 30 divided by 3 is 10. That means that there's a 0.56 that they gave us, and then this 0.3 comma 10 on this curve of this inverse variation. Again, we're not really looking at the graph so much, but I just want to remind you that it's a curve separate from the line that was in the previous lesson that dealt with the other kind of variation. Okay, 2 more. This says a 120-pound weight is placed 5 feet from a fulcrum. So think of like a teeter-totter seesaw type apparatus. How far from the fulcrum should an 80-pound weight be placed to balance the lever? Well, this is inverse variation because basically as the weight goes up, the distance from the fulcrum goes down. This is inverse variation, okay? And the relation is such that it's inverse. So the question then becomes, what do you have to do with the 80 pounds so that it balances with 120? Notice I've got the 120 closer. This is going to be a farther length. Think about it if you're on a teeter-totter with your younger sibling, right? And they weigh less than you. You need to scoot forward. He or she needs to scoot backward in order for you to balance each other. The farther away, the more that you're able to balance that out, okay? And this is the inverse variation relationship. Basically, what we're saying here is weight varies inversely with distance. So I might go something like this. 120 equals k over 5. Now you say, why did you use weight as the dependent variable and distance as the independent variable? I probably should have switched it around. But you know what? For the purposes of this problem, it really doesn't matter. Because in either case, to find the k value, wouldn't you multiply? And you'd get 600. Either way of these, you're going to get k equals 600. Okay? So the k value there is 600. Now, with these to balance out then, the question would become, well, y equals 600 over x, and I want to find the y value when the weight is 80. You could plug that in. And once again, what's stopping you from plugging it into the other variable. Well, with inverse variation, it doesn't even matter. If you plugged 80 in for y and you solved for x, go ahead and try it if you want to. Maybe we'll just do both. It'll come out to the same thing. Yeah, actually, it'd be a good practice to do both. So we'll just do that and kind of prove that to you. We're almost done anyway. Okay, so 600 divided by 80 is like saying 60 divided by 8 is like saying 30 divided by 4, which is like saying 15 divided by 2. So that's 7.5. Y is equal to 7.5, right? And that's a distance, so that'd be in feet, 7.5 feet. Okay, now what would you do with this one? 80 equals 600 over x. This is worth doing. How do we get x by itself? Pause the video if you don't want to know, if you want to think about it for a second. What you would do would be to multiply by x. Some people don't think to do that, but that's exactly what you do to get the variable out of the denominator. You can multiply by x, and these would cancel here. So now you have 80x, don't write x 80, right? 80x equals 600, and then you would divide both sides by 80, and you're going to get 7.5. Same thing we got here. This is not the case with direct variation. Don't think that you can do this with direct variation. With direct variation, we said very clearly you divide the y by the x, not the other way around. Here, it's a product. It doesn't matter which way you multiply. That's really the commutative property. All right. There's your 7.5. Last example says decide if each data set represents direct variation or an inverse variation. Then write an equation to model the data. All right. So let's check direct, then inverse. Let's see if it's direct. To be direct, you'd have to divide the y by the x. 10 divided by 3 is 10/3, or 3 1/3. 6 divided by 5 is uniquely this fraction 6/5, or 1.2. 3/10. These are all different, right? So this is not direct variation. Check for inverse. The product of them, this would be 30. 5 times 6 is 30. 10 times 3 is 30. This is inverse variation. This one is inverse variation. Y equals 30 over x. They said write the equation if you figure out what the variation type is. All right, again, I don't like this. Y equals 30 over x is better. Okay? What about this one? Well, let's check direct first. 3 divided by 2 is 3 over 2. 6 divided by 4. 6/4 reduces to 3 over 2. 12 divided by 8. 12/8 reduces to 3 over 2. Check it on your calculator if you don't believe me. Okay? Now, before we go ahead and write the equation, let's just prove that it's not inverse variation. Inverse variation would be a product. 2 times 3 is 6. 4 times 6 is 24. 8 times 12 is 96. It can't be both anyway. I already proved that it's direct variation. So we want y equals 3 over 2x. Direct variation. It's direct, and we wrote the equation. I'm not sure we labeled the last one. We didn't. Inverse y equals 30 over x. All right, thanks for watching.